Hi friends, myself Sundar Kumar. I'm taking electrical machines as a subject for the mechanical engineering students of second year. In the previous lecture, we are discussing all the construction features of the AC machines, and then the process how the direction of the rotor will be going on in case of the three-way induction motor. Now we are discussing all the top three characteristics of a three-way induction motor. In three-way induction motor, top three characteristics the most important parameter which we are covered under this lecture. And it will be very important and the point of view of the examination, because in case of the final examination, examiner have a unlimited choice for setting of the exam, but this choice is the most important because normally every examiner is looking to develop a paper which will indicate that the concept of the student must be clear must be clear cut in nature. So this characteristics will be covered under the final examination for you. The toxic core induction motor gives us the information about the variation of torque with the slip. The slip is defined as the ratio of difference of synchronous speed and the actual rotor speed of the synchronous speed of the machine. The variation of slip can be obtained with the variation of speed, that is when speed vary, the slip also vary and the torque corresponding to that speed will also vary. The curve can be described in three modes of operation: low slip region, medium slip region, and the high slip region. Over here, we are find that this will be the torque slip characteristics of a three-way induction motor. Under this, we are finding that the first region, which is indicated as the braking region. Braking region where the slip is more than one. From 1 to 0, it will be called as a motoring region, and from 0 to more than 1 or more than 1, it will be, sorry, less than 1, minus 1, less than 1, it will be called as the generating region, or minus 1. If we are saying that the value of the s equal to 1, 0 and s is minus 1. So braking region, motoring region and the generating region will be there. The direction of the speed and slip both are the inversely proportional to each other, because whenever we are seeing all the slip will be moving from the right to left and the more speed will be moving from the left to right. So under this, we are finding that there is a three reasons are there. First reason will be the low slip region. Low slip region means it will be the part below of the maximum. The behavior of the whenever we are just looking on this part, we are finding that the car is follow a linear path, and it will exponentially increasing on at this part. And whenever we are just looking over this side, it will be decline from a point and but not follow a straight line method, and it will be moving down in an exponential format. So over here it will follow a linear nature, but after the maximum value achieving, we are finding that the slip is goes on, the torque will be goes on decreases but in the exponential form, and after a range we are finding that it will goes to start as a straight line. So at the starting, the torque of the machine will be a lower one, and now again whenever we are the speed will be increasing, the torque will be increasing to the maximum, and then again it will be reduced to whenever we have to achieve the synchronous speed, the torque will be goes to zero. There will be the motoring mode. In this mode of operation, supply is given to the stator sides and the motor always rotates below the synchronous speed. The induction motor torque varies from 0 to full load torque as the slip varies. The slip varies from 0 to 1. It is 0 at no load and 1 at steady state. From the curve, it is seen that the speed is directly proportional to the speed, to the slip. That is, more is the slip, more will be the torque produced and vice versa. The linear relationship simplifies the calculation of motor parameter to a greater extent. Naturally, the generating mode, in this mode of operation, induction motor runs above the synchronous speed and it should be driven by a prime mover. The stator winding is connected to a three-phase supply in which it supplies electrical energy. Actually, in this case, the torque and slip both are negative, so the motor receives mechanical energy and delivers electrical energy. Induction motor is not used as generator because it requires reactive power for its further operation. That is, reactive power should be supplied from outside, and if it runs below the synchronous speed by any means, it consumes electrical energy rather than giving it at the output. So as far as possible, induction generators are generally avoided to generate the electricity. Naturally, the braking mode. In the braking mode, the two leads or the polarity of the supply voltage is just interchanged, so that the motor starts to rotate in the reverse direction, and as a result, the motor stops. This method of braking is known as plugging. This method is used when it is required to stop the motor within a very short period of time. The kinetic energy stored in the revolving rod is dissipated as heat. Also, motor is still receiving power from the stator, which is also dissipated as heat. So, as a result of which, motor develops enormous heat energy. For this, stator is disconnected from the supply before motor enters the braking mode so that the motor can get stopped. If load which the motor drives accelerates the motor in the same direction as the motor is rotating, the speed of the motor may increase more than the synchronous speed. In this case, it acts as an induction generator which supplies electrical energy to the mains, which tends to slow down the motor to its synchronous speed. In this case, the motor stops. This type of braking principle is called the dynamic or regenerative braking of the three-phase induction motor. The torque slip characteristics of single-phase induction motor is quite different from the three-phase type of torque slip characteristics of three-phase induction motor. From the figure, you are finding that there is a two torque will be developed in the feed 1 and the feed 2. So the resultant, it will be bluish in nature and it will be moving from the S2 to S1 and then S0. Direction of which are opposite to each other, so the net torque produced is zero. Hence, the motor fails to start. From here, we can see that these motors are not self-starting. Unlike the case of a three-phase induction motor, there must be some means to provide the starting torque. If by some means we can increase the forward speed of the machine, due to which the forward slip decreases the forward torque, which increase and the reverse torque will decrease, as a result of which motor will go to start. From here, we can conclude that the starting of a single-phase induction motor, there should be a production of difference of torque between the forward and the backward field. If the forward field torque is larger than the backward field, then the motor rotates in forward direction or anti-clockwise direction. If the torque due to backward field is larger compared to the other, then the motor rotates in the backward or the clockwise direction. So these are the operation of the three-phase or the single-phase induction motor, and it will be depend upon the characteristics, like which type of characteristics will be followed by for the single-phase and for the three-phase induction motor. Now, thank you for attending the lecture. Thank you.